Thank you. I'm back. So hopefully you guys are not sleepy. I know I was a while back, so that's why I went out and washed my face. So this talk, in the spirit of network administration, we are trying to see if you can visualize and analyze your network. So if you, and this is basically an outline of how the talk is going to proceed. So why did we do this? And this is kind of the motivation of why we did this. So it is fundamentally challenging to identify the interaction between and the impact of the underlying network on the performance of HPC application. So as a system administrator, the typical question that you might get is, hey, you know, my application runs in about 15 seconds typically, but yesterday night between 2 to 3, it took about 5 minutes to run. You know what happened? So these are the kind of questions that sysadmins typically tend to get. So there is no real way for them to give a proper answer to this. There could have been a switch that went down. There could have been like a job that was running there which was doing all-to-alls. So a bunch of things could be happening. So can we create a tool that allows system administrators to answer such questions? And can we create a tool which allows people to delve into the performance? Can you correlate the performance of your HPC application related to what's going on in the network, and bring in information from the job scheduler to figure out what jobs were being involved, who launched those jobs, what are the nodes that are part of the jobs? So broadly, this is what we are trying to tackle here, and this is basically a bunch of limitations of existing profiling tools. So this is the broad challenge that we are trying to tackle. How can we design a tool that enables in-depth understanding of the communication traffic on InfiniBand network through tight integration with the MPI runtime? So the broad goal is that, hey, you have tools that profiles the MPI runtime. You have tools that profiles your InfiniBand or OmniPath network. You have tools that tells you the let's say these many jobs were launched. For instance, Slurm's accounting information database tells you that user X launched so many jobs. They ran on let's say nodes 10 through 20, so on and so forth. But there is no single place where all this information can be correlated and made sense of in a holistic way. So that is what we are trying to address and analyze here. And our answer to that is what is called as the InfiniBand Network Analysis and Monitoring Tool. So again, like every work we do, we try to make these solutions available to the general public so that they can benefit from our work, and we can also get feedback from them to see how this can be improved. So one of the goals of this presentation, at least from my perspective, is to get feedback from all of you guys to say that, hey, this is something, this is not good. It would have been better if you had done this like this. Or stuff like, hey, this is good, but it would have been good if I could get such a view of the system, or like you are missing feature X, Y, Z, so on and so forth. So this is one of the reasons for us presenting this. And the way I'd like to structure this is as a demo. So we have this INAM daemon and this entire software running on our cluster back at Ohio State. So I'm hoping that if the network holds, I want to do a live demo here, and if you guys are interested, you can also try this out on your laptop. So all you would need is a web browser, and you can log on to the cluster back at Ohio State. So with that kind of an overview, let me, okay. So let me try to switch computers and hope for a live demo. So, okay, that's good. So typically what happens is that you would open up the INAM tool on your web browser. So the INAM tool has multiple components. It has a HTML-based front end. There is a Java web server which kind of feeds onto this the HTML front end. There is a database in the middle which logs all your information. So this is one of our most critical components. So as I mentioned in the initial motivating example, how can a system administrator tell a user what happened sometime in the past? So you need all the information to be logged somewhere so that this can be retrieved and people can make sense out of it. So that is where the database component comes in. Now, depending on your wish, you can choose MySQL, MemSQL, Memcached, whatever you want to as your database, and you can back it on anything you want to, like hard disks, store, like SSDs, NVMe's, whatnot. One of the main reasons why we chose like a HTML based front end was because being like a browser based, you can pull it up on your cell phone, on your tablet, on your laptop, desktop, anywhere. So it gives you very good portability. So there are different tabs here. So the first tab is what we call as the full network view. So it allows you to give obtain a, well, the network seems to be a little slow. So I'll go back to the window that I opened up earlier in the hopes that it does show up. Okay. Yeah. So this is the view of the network back at Ohio State. So this is about a 200 node cluster. It's a factory topology. So the rendering here is just the JavaScript's rendering of how the nodes look like. So you don't. This is just a logical representation. This is not actually how the let's say racks and stuff are laid out as. So this is how the JavaScript decided to display these images. Now, as you can see, on the right hand side, there is a let's say a legend which indicates the level of usage. So you have most of the cluster unused right now. You have some links which are being used between 5 to 25%, 25 to 50%, so on and so forth. So if you want to figure out, hey, what are my let's say links which are used or unused, so you can check those things. And for instance, let's say I want to see what's going on this particular node right now. So let's click on that node. Yeah. This is one of the problems with doing a live demo. Your browser sometimes does not cooperate. So please bear with me while my browser hopefully refreshes. So broadly, the goal is that while this comes up, you can dig down deep. So from the entire network level view, you can select one link and figure out what's going on that link. So how many jobs are communicating through that link? On that given job, what are all the nodes which are sending and receiving data? So let's say this is a switch. So if you want, you can go into the switch, look at each individual port and see, for instance, what's happening on this particular port of the switch. So let's say if you click on that, and maybe it'll take a couple of seconds to come through. Okay. So there are different kind of counter information. So like transmit data, receive data, transmit packets. It gives you a bunch of information to see how much data was sent, received, basically what's going on that particular switch. So that is at a switch level. Now suppose you want to see what's going on a given node. Yeah. So if you want to see what's going on a given node, the same thing applies. So let's say you can double click on one of these. Let's say we can see, let's see what's going on that node. So you can click on that node, and the way we populate information from this node is from the MPI. Okay. Now there are different approaches to getting information from on the node. You can have a daemon running on the node. You can have like a remote process querying that, or you can have whatever HPC middleware is running on the node like push data back onto the daemon. So that is the third approach is what we take here. So we have co-designed this network analysis and monitoring tool with the MPI middleware. So the MPI middleware knows what exactly is happening on that node, which process is sending data to which process, what is the collective operation going on, what's the point-to-point operation going on, is it RMA, what is the level of intra-node data being transferred, what's the level of inter-node data that is being transferred. So if you look at this particular node level page, you can see that this node is currently part of job 524460, and there are 4 other nodes which are part of the same job. And this is the CPU usage, this is the virtual memory usage, this is some communication buffer usage that is specific to MPI, and you have a bunch of counters, and you have a communication metric. So it tells you what all ranks are on this particular node, what cores they are bound to, and what sort of communication each rank is doing. So let's say if you want to figure out if it is performing collective operations, or so here basically from this graph what you can gather is that this process is performing a lot of send and receives, and a lot of it is actually collectives. So you can figure out if it's collectives, or for instance, like is it RMA, like MPI3 RMA operations, or is it intranode operations? How much of it is intranode? How much of it is intranode? So on and so forth. So because we have data from the MPI library, you can dig in deep and figure out how the various metrics correlate with each other. And finally, there is also a communication grid which says that to which node are the processes on this particular node communicating to. So this information is particularly useful if you want to figure out what is actually going on the network. So let's say from the network level view, if you saw that one of the links was heavily used or being marked in red color. So if you want to figure out what was happening on, let's say, this particular link, you can open the link information, and then INAM will tell you that what is currently happening on this particular network. So this is analyzing this network at the network level. So this is getting information directly from the switch or the router. Now if you want to go, you can go to the job level. So what INAM will tell you is that, hey, on this particular link, it is job X, Y, or Z that is using the network. Now from this job, if you want to go down even further to the process level, you can say you can also select that, and then INAM can tell you that, hey, you have on this particular physical link, it's a duplex link, right? You can do transmit or receive. So rank 0, 16, and 8 are receiving data. So basically this is the half of the duplex from the switch to the node. So rank 0, 16, and 8 are receiving data, whereas ranks like 24 or whatnot are sending data. So basically the goal here is that you can dig into whatever level you want to. You can start off from like a whole network view, go in down like as far as to the process level. So let's say from the network you can go into a node, from the node you can go down to a job, from the job you can go to a process, and there are all sorts of correlations that you can try to get. Now on a different note, so suppose you want to figure out what are the various jobs running on the network and what is happening at, let's say, a quick glance. So there is this page called live jobs which tells you what are the various jobs which are currently running on the network, and what percentage of those jobs are actually sending information to INAM. So if you look at this, you see that there are some jobs which are actually sending information to INAM, and there are some jobs which are actually not sending any information to INAM. So these jobs are being run by an MPI library which is capable of sending information to INAM, whereas these jobs are not built with that particular support. So that's what you see here. Now from this page, if you want to see what's going on for this particular job, you can go directly to a job level page. So this is kind of a node level view of what is going on, and if you can also have a job level view saying that what is going on for this job as a whole. So what is the CPU utilization for this entire job? So the benefit here is that you can do analysis at different granularities. You can do an analysis at the entire network level. You can do an analysis at the job level, the node level, the process level. You can try to figure out what's going on a given physical link. Basically, all of this is made possible by the correlation of information that INAM collects from the network, from the MPI library, and from the job scheduler. So this is let's say a quick demo of what INAM is. So before I kind of head back onto the slides, do you guys have any questions on what has been presented so far? Any thoughts about good, bad, ugly? Yes?
How far does it go back in time?
So, the question was how far does it go back in time? Okay, so INAM has two kind of views. One is a live view and the other is a historical view. So if you want to go, let's say if you have infinite amount of hard disk space, you can go as far back in time as you want. Now to give a more specific answer, this depends on two factors: how frequently you let's say grab data from your network and how far you want to go back. So for instance, if you grab data from your network once every 30 seconds, probably you can go back like a month or so with like 100 gigabytes or so. But if you are grabbing data from your network once every second, or once every 2 seconds or 3 seconds, then probably you can't go that far back. And this is completely configurable. So we have some models that are available on website which tells the users that, hey, if you have a cluster with so many switches and so many nodes, and if you want to query the entire like fabric at X seconds granularity, then you would be generating so many gigabytes of data every 5 seconds, 10 seconds, so on and so forth. So based on that and the amount of hard disk space you have, you can figure out till what date in the past you want to maintain the information. Sorry, yes?
How intrusive is the monitoring? That being, how much jitter does it cause to the network or the applications themselves? How often can you monitor without causing significant amount of...
Right, that's a good question. So we actually did some evaluation. Yes, so the question was that what is the impact of running INAM on HPC applications, to be succinct. So we actually did some where we ran some standard HPC benchmarks. So as you can see, there is very little degradation to the performance. So this basically shows the impact of the data collection on the MPI side on application level performance. So this is just basically point to point, and this is showing the impact on the collective performance. Oh, okay. Okay, sorry. Okay, so this is basically the impact on latency and message rate. So here we are measuring like multiple things. So one is the impact the data collection from the network has on the performance. Two, the impact the data collection from the MPI library has on the performance. So as you can see, there is very little impact for your communication operations at a micro benchmark level for point-to-point collectives or some standard benchmarks like NAS. So we actually did some evaluation, and we don't see any significant impact for this on the performance of end applications. Now there are two modes in which you can run the daemon. You can say that, hey, query every single port on the network, or you can say that just query the switches on the network. So the reason why we gave these two modes is because we ideally want this to be used with help from the MPI library. So if nothing is running on a node, then there is no point in me trying to figure out what's going on in the node. And if you have an MPI library which is capable of sending data back to INAM, then that is going to do it, and there is no point in the INAM daemon querying the port on the node to figure out what's going on. So with this, we have been able to run INAM successfully on the Ohio State Supercomputing Center clusters, and we were able to get fabric information at a granularity of about 5 seconds for I think the entire cluster is about 2,000 odd nodes. So we have been able to run this on the OSC cluster. Unfortunately, I was not able to show a demo there because they are behind a firewall, but we have run successfully for over like a few weeks now. Sorry, there was another question here? Okay. Any other questions, comments, thoughts before I head back onto the slides? Yes?
So the data that you were showing before, were those just the raw counters, or were you calculating the
So it depends on what counters it is. So I was showing multiple kind of counters. So one was XMIT packets, receive packets. So those were actual counters from the HCA or the switch. There was another level of information I was showing which shows collective packets and collective bytes and things like that. So that was like data that we computed. Now on the link, I showed a demo where we were saying that, hey, on this link, job X was contributing to this percentage of traffic. So to the best of my knowledge, there is no way for me to like tag a packet on the network to say that, hey, like this packet was what was going on the network. So like if you have like, again, maybe Jason or others from Mellanox can help me out here. But if you have some like flows or stuff like that, we may be able to do it, or like VLANs, virtual lanes. But that is typically not deployed on most supercomputing systems. So what we do is, from the MPI library, we know that A was talking to B, and we know that if A was talking to B, then what path in the network it would have taken. So we correlate that information with the information we get from the fabric as to the amount of actual data that was going on, and that is how we are able to say that A was talking to B during this point of time. I know this from the MPI library. I know from my fabric that this link was being used at 80% utilization. So then we make a correlation as to what percentage of that 80% was contributed to by like job A, job B, or Prosper A, B, and C. So that's basically how we are able to do that sort of correlation. Yes?
So yeah, one of the tricks we use is to tag the connections with service levels.
Right.
So do you handle service levels in this scheme? And so, you know, we'll do that for I/O and lots of things. It's pretty static. It's not very dynamic depending on how you configure it. But we'll merge that in with QoS as well. So.
Right. So for that to work, we need to have multiple virtual lanes on the network. So to the best of my knowledge, the IB has per virtual lane counters. It does not have per service level counters. So that means that the system administrator will have to enable multiple virtual lanes on the system. Maybe you are lucky, but unfortunately, no system administrator that I have contacted in the last 10 years has deigned to enable virtual lanes on their system. So that's why we didn't go by that. But if that is done, then definitely we can do it, yes.
So certain versions of the switch have the SL counters.
Okay.
And yeah, I mean, the VL stuff, we're using that for
Sure.
various purposes. So.
Yeah, so yes, if you have VLs, definitely, then this definitely can be done. But the reason, as I said, why we didn't kind of pursue that is because of the immense resistance we face from system administrators to enable virtual lanes. But maybe at NASA it's different, and I'm actually happy if that can be done, because that gives you much more accurate information. So here we are trying to make a best guess based on the information we have. But if we have per virtual lane level counters, definitely that will be much more accurate. Yes. Sorry.
You mentioned previously that, you know, when node A is talking to node B, you know the route it's going through, so you kind of know which switches it's
Yes.
going through. But what if you had a fabric that had multiple paths to each node in adaptive routing? How would you be able to figure that out?
So the question was, what would you do if there are multiple paths to the network, and what would you do if there is adaptive routing? So multiple paths, if you're talking about the LMC feature, that is still static, so we can figure it out. But adaptive routing is a new challenge. So that's something that we are trying to figure out how we can exactly address it. Because with adaptive routing, I can't really say what is the path being taken. That can dynamically change. So we still don't have access to an switch that has adaptive routing. And we are not exactly sure when that will come out, but that is a challenge, and that is still a research question that we are trying to see how to tackle. Thank you guys for all the feedback. I appreciate it. So I think I have another 5 minutes or so left. Any other questions? Okay, if not, I can kind of go back to the slides. So what does INAM have? So as I mentioned, INAM has 3 components, and each one of the components can reside anywhere. So you have the front-end Java web server that can be on node 1. you have the database that can be on node 1 or node 2 depending on how your configuration is, and there is also a daemon which collects information from the fabric as well as receives information from the MPI and also gathers information from the job scheduler. So it is the daemon that's kind of the heart of the entire system, which grabs information from multiple places and puts it into the database, which allows the Java web server to grab it and display it in a easy to use fashion. So this is at a high level the design of INAM, and the daemon has multiple threads in order to enable scalability and parallelism. So if you want to discover the entire fabric, so we have a thread for fabric management, we have a separate thread for collecting MPI data, and this is something that we are working on. So how many of you guys have heard about the MPIT events interface? Okay. I guess mostly people who are working in the MPI forum. So for others, the goal of the MPIT events is that so currently, when we did INAM several years back, there was no standardized way for the MPI library to kind of push this information back out to your tools. So the MPI tools events interface is a way to achieve that. So what the events interface does, to put it in a very succinct fashion, is to generate an event when a particular occurrence which the user asked the MPI library to monitor has occurred. So it is basically a callback which can be used to send information to let's say any outside tool like Tau, HPC toolkit, or INAM if you will. So once you have this, there is a more standardized way, a more generic way to make this kind of data collection applicable to multiple MPI libraries. So currently this is only applicable to MVAPICH 2 because that's what we develop and that's what we are more familiar with. But going forward, we want to make this applicable to different kind of MPI libraries like OpenMPI or MVAPICH 2 to ensure that there is like more applicability of the tool to end users. So this is again kind of going back to what I had mentioned earlier. We have like different kind of threads. So as I mentioned, the daemon has like multiple functions to perform: gather data from the network, gather data from the MPI library, and gather data from the Slurm or any let's say cluster manager. So different threads are tasked with these different jobs, and based on the load and the amount of time it takes, the number of threads can be dynamically modified by the system administrator. So for instance, as a sysadmin, you know that you have a 2000 node cluster. So for a 2000 node cluster, you might need 4 or 8 threads to kind of query the entire fabric in a reasonable amount of time. This is particularly important if you want to query the network with the granularity of let's say 2 seconds or 5 seconds. If you are going for a much larger granularity, then that's not a problem. But if you want to query the network with a small amount of granularity, like 1, 2, 3 seconds or even less than a second, then you need to have enough number of threads to gather that information from the network. So the system administrator need to be aware that the INAM daemon is going to be a pretty compute intensive thing, and it should probably be given like a node of its own to ensure that it is not bottlenecking other tools, for instance like OpenSM. So this is kind of a typical deployment scenario that we suggest to users. And as far as the database goes, we have some modeling to tell the users as to how the database can grow depending on the size of your cluster. So that the system administrator gets an idea as to let's say how much data that I will collect. And we also have mechanisms to automatically prune the database once the size grows past a particular limit, or we have collected more than X days of data. So for instance, if you are only interested in the last 3 days of data, so you can tell INAM through a configuration file that any data which is older than 3 days, please delete it. So these sort of automatic pruning features are also available. And I'll just skip this. So I think I've presented most of them. So to summarize, the goal of INAM was to see if we can present a one-stop shop, one place where you can get a holistic view of what is going on in the entire network, where information from the job scheduler, from the MPI library, from the fabric are presented in a unified fashion. So you have tools to do each one of these things separately, but can we do it together? So this is why we had created INAM, and this is our goal. And going forward, some of the things that we want to do is to go in further and figure out what is going on inside a node. So for instance, let's say between sockets, which processes are talking? From GPU to CPU, what is the communication that's going on? So these are the kind of things that we want to pursue going forward. With that, I come to the end of my talk. Thank you for your patience. Yes?
Are these tools open source?
They are not open source, but they are available freely for download from our website. Any other questions, comments, thoughts? Yes?
Have you tried testing at scale to see how much data this database can hold?
So we have gone up to 100 gigs. We did our scalability testing on the OSU cluster. We ran it on a Haswell node, but unfortunately the physical node itself only had 100 gigs, and they were unwilling to go beyond that. So that is the maximum that we have allowed the database to grow. And with 100 gigs at about 5-second granularity, we were able to hold 5 to 7 days worth of data for the entire cluster. So this is again completely depends on how much you as a system administrator want to store. So if you want to store data for a month, then you should be willing to dedicate that much disk space for it. And we have some modeling which tells you how it is projected to grow. So the short answer is that 100 gig is the maximum that we have collected. That was about 5 to 7 days worth of data for a 2000 node cluster. Yes?
Do you do any basic data analytics that will, let's say you have congestion somewhere on the network or something on one of the nodes. Do you have some kind of
like a trap event to email the sysadmin?
Like a color code thing that the administrator can look at and say, oh, hey, I have a problem here in this network.
So it is already color coded. So I can show you offline. So if you look at the full network view, it is color coded. So red stands for like 75 to 100% utilization. And we can also measure like different kind of counters. So typically, if you look at the transmit discard counters or the transmit like wait counters, these are what indicates congestion in the network. And we have different views of the network to show those kind of things up. And one of the requests that we have gotten from the supercomputing center in Australia was to create like trap events so that you can send like SMS or email to users saying that, hey, something bad is going on. So those are like features that we are working on and hopefully will be releasing in the next 6 to 8 months or so. If there are no more questions, I'd like to thank you for your patient listening and have a good day.